Good morning. Thank you for your time. This webinar is going to be on dbMap, and I'll start just very briefly with an overview of Petrosys. My name is Paul Gibb. I work for Petrosys in the UK. Our main office is in Glasgow. We have offices around the world. We're an Australian company, initially founded in 1984, but we were bought last June, by a Canadian company, a group called Constellation. And this is a significant change from what was a smallish independent software company becoming part of a much larger organization, and it's given us quite a lot of reach worldwide, plus a lot of technical and commercial input into our business. So it's been a good move for us. As a company, we focus on data management, connectivity, exchange, surface mapping, and modeling. You might be most familiar with the Petrosys Pro mapping and surface modeling application, but this talk will be about our dbMap. We focus on the oil and gas sector, and we have a broad spectrum of clients worldwide, ranging from smaller independents who would typically be using a pro for exploration work, appraisal work, through to larger organizations and national oil companies who could be using the Petrosys Pro as well as using our dbMap data management solutions. So just a quick overview for those that haven't encountered us before. We do mapping and modeling and surface modeling and volumetrics using our Petrosys Pro. It's a desktop-based application. It's an application that has a very powerful connectivity, which we'll touch on today, that allows that application to work with data stored in other applications. It could be Landmark or Petrel or Paradigm, but it's an independent mapping and modeling application that sources directly from these other applications, and then it can put back into those applications the data that it's created. In terms of what we're going to look at, data that is sourced and stored in dbMap, and again through Exchange, how that data can become available not only to Pro but to other applications within Schlumberger or Landmark domains. So we have a PPDM based data model. We're using the standard PPDM 3.8 data model with some extensions brought forward from 3.9 for particular data types. We've been working with PPDM since 1995, and we have very strong coverage in wells, seismic, and records management, and those will be the focus of this demonstration this morning. But we also use other modules from PPDM, which include the audit history, data dictionaries, and business rules. And this helps us when we're building our relationships and looking at the data through time that's stored within our database. The database itself is hosted on Oracle. And if I go through just a few slides here to set the scene, the central repository is where we'll store all the data. This is dbMap, and you can store your header data, surveys, tops, reservoir properties, cores, tests, seismic. This is where you'll put all of your QC'd data. Once you have your data stored, you can use a number of viewers to view the data. We have the desktop viewer, which is Pro, so you can view data in a mapping sense. So that would be any sort of data that you might want to lay, so leases as well as coastlines and field outlines, and then well information could be built up as layers on a map. Or we can use the dbMap web module, which will allow users to look at the content of the data in a tabular form and look at lists and build queries and extract data in that form. Both interfaces suit different workflows, and both are available for users to use. Once you have data in your database, there's often the need to get the data out and put it into interpretation suites. So we have our Exchange tools, which will allow you to then move data from your master data repository into your operational data stores and project databases. A number of companies that we work with also have GIS stores using Esri. So while we can store GIS data, it's one of the capabilities within PPDM where you already have a system that's set up to store and manage your GIS information. We will create links directly to that. So we are aware of what data is in that store, and we can indicate through a search what types of data might be available to the users in combination with other data that you've got in dbMap. We also do records management. So where you have documents, unstructured data that are on file systems, or where you have data that is in a warehouse and it might be core samples or fluid samples, we can catalog that information and associate it with wells or seismic or the structured data that's in dbMap. So when you do a search of the data, you're able to see not only what is stored within dbMap itself, but also what related information, hard copy information, is available that you might want to go back to and read through or reference when you're doing your work. And the last piece there is the services side. So we help our customers when they implement a dbMap solution. We also, because PPDM is a very flexible data model, there may be some specific instances where data types are not included in the standard data model, so we can build extensions that include and incorporate other data into the data model. So your data model is capturing all the data that you need for the particular type of work that you're undertaking. So that's often done as a custom piece of work. And then also things like our services team are available to help when you have projects that require you to load data, or you want to set up some rules for how you'll manage your system. And we'll come to some examples of those in the demo. So just another slide to look at that same concept. We have a number of modules that we make available through dbMap. Just in summary, the wells, the records management, the seismic. We have other modules which we won't go into today, but they're leases and permits and basins. So we have the modules where you'll be storing your data within dbMap. We have a number of desktop functions which include the visualization of data, but the exchange and the management and loading of data. We have the web interfaces, which we'll start off with shortly. We have the connectivity, which is how we'll then exchange our data directly with companies like Esri and Schlumberger and Halliburton, and records management. So when a company chooses to work with our solution, they don't need to purchase all of the modules. Particular clients will take those modules that are relevant to their business. So client A, for example, might only be interested in a well master repository with a records management component, whereas client B, for example, might just be interested in a seismic data repository with records management. So you would only take the modules that you require for your work. So I'll just switch over now to the demo. This is the interface that we'll see. So I'll just change screens. This is our opening interface. I've logged in as a user called Tester. When you set up your system, you assign specific permissions to each user account, and that could include what modules they'll see on their interface. In this example, I've got sight of all of the modules that I have in our database. And that user will be assigned permissions as to whether they have read or write editing access to the data. You might, within your organization, have a number of key users who have full permissions, but the majority might just be browsers and visualizing what data is available. So that will all be set up within the user's login details. So the modules we'll look at in this demo will include wells, we'll look at seismic, and we'll look at records management. And I'll start with wells. And in wells, each of the opening menus require you to search first of all for data. So we could just hit search and I'll let this run, and it will look for all of the data that is available in the system. So it will just take a second or two, and it will build up a list for me of all of the data. And we can see down here on the right, I've got 70,000 wells that it's brought back. These wells, there's a combination of data from around the world, which is public data that we have acquired and loaded into our system. If I want to do a more advanced search, we have built some search capability that allows users to build more structured searches. So we'll just bring that up. And I could, for example, say I'd like to find all wells that have check shots and directional surveys, and let's say tops. So it'll build up my list here and now perform a search based on whether check shots exist in this well, directional surveys and tops. If you want to be a little bit more specific about the depth range for those tops, we can put in much greater constraint on that search, and then it will only find the wells with the tops that have a particular interpreter or depth range that might help us get to our data much quicker. But I'll just hit OK now. It should bring back a much shorter list of wells for us to look at. So as that's loading up, I'll just go through. On the left-hand side, we have a tree filter. So again, we've predefined a number of options for you to filter. It could be based on country. So we could go through and select wells that are drilled in a particular country, and that would again further filter that list. We have, again, the option through the top of this table here to type in text, which will then perform a filter much like you have in Excel for a particular text string within these wells here. So if I was to filter for just unknown along the top, or just, not I, won't find I know. So I'll just let that run, then I'll change that text. So come back, unknown. So again, that will further reduce my list. So just come back, searching. So I've now got my list down to 1,332 wells. So once you have a list, you can actually save it. If it's a working list that you want to work with frequently, we'll just click on Save, and that will bring up a list here. You can either have a private list or a public list, which obviously everyone can see the public, but the private lists are yours. And then I'm going to just choose a well here. So once you've filtered and chosen your data, we can then start to look at what data is available. So on the right-hand side of this window, what we have is a summary of the well header information. So when we're loading up data, and this might have been loaded from a LAS file, we'll read the metadata within the LAS file and then populate the header. It will populate as much of the data as it can that's in the file, but we can, as users, then come back and modify that data. But let's just have a look where we have at the moment. So we have typical information like UEs and well names and primary source of the data, an operator, and statuses for the wells. We assign a UE when loading the data. So this is a UE that is assigned by Petrosys, the dbMap database, but we can also load wells with the UEs that you would prefer to use. So there'll be a consistent UE for a well across not only dbMap, but perhaps in your landmark database or in your Petrel reference project. So we could load that and instruct it to use that UE as well. We have some information on the depths that are related to this well. So the ground elevation, Kelly bushing, we should, where it's available, also include the loggers and final total depths. We've got some location information. We'll just go through these very quickly. Dates, miscellaneous, information relating to data acquisition. And I'll show this briefly, but I'll come back to this in a bit more detail. Data quality. So as you're loading data to a master repository, through time, you'll actively manage that data, and that quality will improve and your confidence in how good that data is will improve as well. So we can assign a level of quality to the data and confidence. As I say, we'll come back to that because there's a few elements to look at first before we do. So I've got a list of wells here. This is a summary of the quality flag here on the left, and I've got information in my table. At any time, you can come in and use this small cog here, and this will just change the order of the interface so that you can actually see the columns and the information most relevant to the type of work that you're doing. So you can come in and you can drag out rig release date, for example, or let's just remove the primary source and they will be moved from our list. So we click on a well, we view the header data, and then we can scroll down and start to look at more information just relating to that well that we've highlighted. So we've got a list of tables that are here in our wells module, and I can see very quickly the ones that are highlighted in bold and have a figure after them indicate that there is data. And I've got 42 tops. I've got one check shot survey loaded. I've got some well alias information and possibly some basins, fields, and permits data, a directional survey, and some information on well areas. And that's just a quick visibility to the data that's in each of these tabs. But if I were to look at tops, because I know I've got some data there, I click on tops and it will then populate further down in my screen all of the tops related information. We have a very similar cog here that will allow you to filter these fields. And again, if I click on a top, on the right hand side, it will then give me tops related information. So we just let that come up. Here we go. So I have a summary here now of the tops related to that particular row that I've selected, which was the Niobrara white specks. And I can populate further information around that, again, including data quality. When you have information here, we have the option at any time where you see this icon here, is that if I've built a search and I've looked for some data and I just wanted to output that data, we can quickly grab data and move it to Excel. A lot of folk like to make tables of data and build up information in Excel, so you can very quickly extract and put data out to Excel. I won't at this stage. I've got an option here. It's saying that my quality is out of sync. I can hit recompute. Before I do that, I'll just show you what it's computing on, and this is how it's working for quality at all items through our database. So in this particular instance, I'll just click here, and it tells me that all of my rules have passed. So for tops alone, I have selected 5 rules that the database should check when my tops are loaded or when information is updated within the tops table. So if all of these items are met, in this case I've got 3 high rules and 2 medium rules, my hemisphere on the right should be green. So I'll just recompute, rerun that. It's just out of sync. It should come back and it will just confirm that it's green, which is fine. So all of my rules have been passed. The rules that I've set for quality have been measured. But in this case, my confidence is unknown. So on the left hand side of this sphere, it is gray. So I could come in and edit the confidence. And I'll explain the two. Quality is something that the system can measure. So we have rules where when you load the data or where something is updated, the quality can be checked. So do I have an interpreter ID assigned to this? Is the top shallower than the TD? There are rules that can be measured against other information, and therefore the computer can compute the quality. However, with confidence, it's far more subjective. It's up to the individual to choose. And in this case, in my reference table, I have 4 options for confidence: unknown, high, medium, and low. As a data administrator, you might want to have a more fine-grained measure of confidence, so you can add into your reference tables a number of other options that the users can select. But if in this case I just choose, say, medium, I've changed the fields, but I must also give an indication of why I have changed that field. And that's not just for my benefit, it's for other people who are looking at the data. So in this particular case, I'm going to say it's based on an internal assessment. And that could be a group meeting where we decided that particular tops were the most appropriate or best tops for users to use. And I could add a flag into there and say edited by PG. By PG, and then I'll click OK. So as it'll go through now, it'll save these changes, and the left-hand side of my sphere should be yellow. I can see it already here on the left-hand side. But as it updates, I've now got a very visual site on a good quality well with medium confidence, and I can use that as one of my search criteria in the future. So I'll just show you a different example of that in a moment. But if we look up, again, you could at any point in regard to this particular well, look at other data that's associated with that. So I have check shot information. Again, very similar format. The information is displayed on the left, and then I have much more information in this table on the right. With this particular one, I can click further down, and I can actually look at the survey points in this well for the check shot survey itself. So I've got the data, and again, should I want to, I can just export that to Excel. But this information is stored. Again, I can check it. I can offer a quality and confidence flag against my data here itself. So if I just go back up to here, so my quality is, in this particular instance, is medium, but I'll leave that as is. We could have a look and see what other data I've got associated with this well. I'll just have a quick look at RM. I don't think in this particular instance I have any records. So with this well, I've got no physical records attached to this well. And I could look at some other wells and choose data where I have. But we were looking at quality and confidence, and you've got the option here now as one of our filters to start filtering only particular data, let's say with medium confidence quality, sorry. It'll only bring me back those wells in that list that have that level of quality. Just take a second. So there's my option. So when you come to, as a data manager, you're looking to manage your data through time, you could be setting yourself tasks every quarter to go through and look at the low quality data. So you could just build a filter for the low quality and start working through that data and assessing why it's low quality and looking to try and find the information that's required to move that up in terms of medium or high quality. And that's a way of building trust in your data such that when your end users start to build queries to extract the data, they could, as well as looking for data within a particular basin, say, right, I only want to find the medium or high quality data as has been saved or measured by the data manager and my peer group. So we've got the options to save that, and it does make searching in the future a lot easier. Just go through a few more of these. On the queries side of things, we have a number of queries that we've already built for you. So there'll be a number of queries that come with the system. You can look for tops, and on the right-hand side, it'll show me. I should have a. Yeah, just took a second there to come up. On the right-hand side, it will just tell me who's actually prepared this query. But also, you've got some of the in some of these a lot more of the SQL. So if you have the knowledge to write SQL, you can write your own queries and then save them. And for those that don't have that capability, they can then just select from that list that you have. I've got lists of all of my queries, or I could just filter for those that I've used recently. it just makes a different way of searching for particular combinations of data that users may want to see. In this particular example, I showed you my list, which is where I'd saved, but we could also search based on map extents or database polygons that I might have. So you've got aerial and spatial searches that allow you to bring back your data. Okay, so that's just a quick overview of what we have on the well side. If we look at the seismic, we look at seismic surveys in this particular case. We're loading up here into dbMap, into Seismic, all of the navigation information. So I've got the options here again. If I want to use an advanced query, or I'll much more quickly just choose that I want to just filter on the 2D and the 3D seismic surveys, and that I might also choose to pick where I've got high quality, and it's just filtered for the particular surveys that meet that criteria, either that they're 2D or 3D and that they are high quality. And when I select on one of those, again on the right hand side I have more information relating to that. It might take a moment or two here, but with data like when I'm selecting groups of wells, or with seismic itself, a map often is very helpful. It just gives you that view. This is using Bing Maps as our background to this area, so I can see that this is pretty much located where I'd expect it to be for an Irish Sea 3D seismic survey. On this, each time we run a filter, either search advanced or through our queries, it'll build up the filter that we have here. So if I cleared those, we just hit clear, and there is some seismic in here that I would like to look at. So I've got some seismic from New Zealand with the name Stratford. So I've got some 2D and 3D data for Stratford. So if I just click on my 2D for Stratford, that would change its location. It's actually down in New Zealand, so we'll let that find it itself. But I have a number of lines with my 2D. So I've got 13 lines loaded, and I'll just choose 22. It'll build up my information on the right here. Okay, so I could look at each one of these lines. I'm just looking to see my RM catalog. It's not loaded for those lines, but what I've loaded here is all of the 2D navigation data, and I would then look at a link directly to my segway, which we're not storing in the system. This will be a managed outside of the database, but it will be in a file system that you would set up, and we would be pointing to where that data is stored. I go back up and we'll start a look in the records management. The similarity in all of the tables, we'll go to records management in a second, but all of the options for either selecting and toggling on particular wells, saving the lists that we've made, viewing the data on maps, building reports and computing the quality, these items and the interface for each of the modules is the same. So we'll just go here then to records management. So if I did a search here, there's just one slight difference on our search option. I can search for the common name. So this could be within the name of the file itself, or within the file directory structure that we're going to look at, or whether the document itself contains a particular name. So I've got some information which has the word cliff within it. So it will search for any file within my system which has cliff in its file name, or within the content of the actual file itself, be it PDF. So I've got a number of files here. I'll explain, I've got a few slides afterwards how the records management piece works, but essentially we've set up the dbMap database to search particular directories on your system. So we won't necessarily search every single directory, which could take an enormous amount of time. You might have chosen areas where you have either seismic or you have your cultural information and you have records, and we're pointing basically a cron job which will look at that directory structure and then catalog the information. So we've got data here which is being cataloged. I could look at this particular example here. It's actually got Cliff in the name of the file. The one below it doesn't have Cliff in the name of the file, so it's brought back 8 items which have met my search for Cliff. And I could actually take a look at this file, and you've got the option to preview any of the records that we've cataloged. And I can see that not only was it in the name, but Cliff is within the file itself. So I've got a cross section here relating to 3 wells with the word Cliff. If you've got, when you're loading data, we have the option at the loaders to catalog and do quality control. Sometimes if you've loaded up some information manually, you may then want to come down and look at the wells. So there were 3 wells that were there, and you might want to assign additional wells. So in this particular case, that document, oops, sorry, my mouse just moved. Cliffhead 1, 3, and 4 was a cross section through 3 wells, and really it should be, in terms of records management, assigned to 3 wells. So in this case, it's only assigned to 1. So you can manually assign this document to the other 3 wells. So if I put in here, well name and Cliff head, it's just building the filter, and I could choose Cliffhead 3 and assign. So when I go back to my wells module and I did a search for Cliff, it would come back and tell me that I've not only am I looking at the actual well data for Cliff, it would say that I've got a record that's been assigned to this well. So it's now assigned to 2. I could go through and assign it to the 4th well, but I won't in this case. So just to go back, again, very similar interface. It's designed so it's very easy to use. If you've just worked principally with the wells module, you'll be able to move into the seismic or to the records management module and use the same processes and same workflows to find your data. It's quite intuitive. I'm using this web interface only at the moment, but you could use the Pro desktop if you're much more interested in using map-based searches. So just while we're here, we'll just look at some of the data exchange. I'm not going to load any data, but we can load data from the web interface. I've got a number of predefined loaders here. These can be built as per your requirement, but I would just choose my well header loader, and essentially we would go through, select the file, and then set up a number of controls that we want to happen as we load that data. And this one here, for example, the CQ, is when I load the data, do I want the confidence and quality check to be run while the system is loading up the data? And this may make the loader a little slower, but it also adds value by defining the quality and confidence so that your users can very quickly start working with data that they might want to filter on based on high quality. Okay, so just one final view, which I didn't show you with the wells. When I select a well, go to this one here. It's just refreshing. We have the option here on the records management side that we can either load logs data into our system, and at the moment we load last data, Whereas with the records management piece, we would be cataloging all of the external files, be they LAS, LIS, or DLIS. We're loading, or we're building with the intention to load more and more data on the log side to the system, but at the moment we'll load only the LAS data, but you still have, through the records management piece, the ability to assess all of the data that you have in terms of log data through the RM catalog. Okay, so I revert to the presentation. Let me just move back. Let's bring that up. Okay, so for those of you who have seen Pro, this is the Pro interface. So for mapping, again, we would sit directly on top of dbMap as well as other applications. So the Pro will connect directly to Petrel and to OpenWorks, and we can build up a visual assessment of what data is available using the map-based interface. This data here is the same data that I would be looking at in the next slide if I were using just my map view in the desktop. But sometimes with map views, people would like to include them in presentations or make presentation quality maps. This would be the better tool for you to do that. The background here is just a Bing map. However, on each item, whether you're here in Pro or in the desktop, in the web, each item can be clicked on and you would then be able to see information. So in this case, I've clicked on the 3D survey and it's brought me up the same table, which will give me the information relating to that survey. So when you're in a map-based search, you still have the same capability to delve deeper into the content of what's being displayed and build up a strong understanding of what data is available. Looked on the records management just by way of another example to the Cliffhead example. Again, we've got core samples that are stored in a warehouse. So where we have images, we may also have reports. It allows, we went to a particular client whose core warehouse was 100 kilometers away from their main office. So rather driving in hope that there might be data there, once you've got a proper catalog of the inventory of data, you can visualize quickly how much of that core has actually been preserved and is retained, and the report that might be there, so that when you do go to your core store, you're confident that the information that you're looking for is there and it's recorded. We talked about the records management piece. I've just captured some of the scripts that will run in the background. We have cron jobs for loading well logs, for doing the confidence and quality, and the last one at the bottom there is the records management. So we would set up cron jobs. You would, as data managers, be able to configure these yourselves. There's a file which is the Petrosys sh file, which you would then say which particular directories your data was stored in. So the cron would then run through those particular directories to search for data. And in this case, I'm running a cron job every quarter of the hour, but you could set this to run hourly or nightly or weekly. It's your decision on how frequently you want to run the cron job, and for it to then look for new documents that might have been added into the system. We have, for all mostly data managers, but for all managers who want to visualize what information is available, a series of dashboards that you can configure to look at information. This is a quick summary of production for all of the wells, and I've done a filter here on the United States. On the left-hand side, you can see the tree filter, and it would just give me a very quick view. You can have dashboards that might be set up to look at the, in this case, the number of wells that have been spudded either by month or by year, what country they might be in, what basin they might be in or field. You can start narrowing that down as per your own choice. In this case, I've got a dashboard for quality. I've got wells, in this case, for Rocky Mountain, and I'm looking at the overall confidence and quality along the top for all of the wells within the Rocky Mountain area. But then I've made a filter based on status. So I can also look at the quality and confidence based on those producing a particular fluid. And I can still see that I've got some wells with an unknown quality that I might want to, as part of one of my quarterly reviews, set myself to go and find out if there's data that can be added to improve the quality of that data. Again, as a user yourself, we have from PPDM itself, they set 3,000 quality rules, and you're able to load up particular rules that are relevant to your business, and we can help you do that. In this particular case, I've got a number of rules that have been set, and just as an example, rules where the criteria is not met, areas where I need to go and redress the status of a particular well are checked for failing, and rules where the criteria has been met have been checked for passing. So these rules can be different per data type. Obviously, the rules that you would have for seismic would be different to the wells. The rules that you have for tops would be different to the rules that you have for check shots. So you can set these up, and then as and when you update or load data, these rules will run as per your cron job and update your system. We just looked very quickly at the loaders. Again, we've got a number of loaders set up where we're using the web interface to load data that we might have put in a file directory. But we also have Exchange, and this is where we're moving data between not only dbMap and other vendors' project databases, but between other vendors' databases. For example, data can be moved directly using Exchange from OpenWorks into Petrel, or from Paradigm into Petrel. But in the purposes of this demo, I would want to move data from a Petrosys dbMap data master into a Petrel working project. So I would use my well import wizard, and I would extract and push all of those wells into a new Petrel project. So just by way of a summary, and I'll open up the screen in a second to check for questions. The solution is very broad. We're covering the wells and the seismic and assets and records. But within that, you may find that there's particular data types that some databases don't cover, but the PPDM data model itself is extendable and configurable. And we've started and are doing work for a number of clients around extending that into non-seismic data capture, so around gravity and electromagnetic and PVT data. So it's a model that can grow as new data types become available and become useful in your subsurface workflows. By building a repository, we want to ensure that that data will integrate and work with other applications. So as well as the import and export using various files, we have the Exchange option where you can move data directly from an application into dbMap and master it, or from dbMap into a working project. One thing I didn't actually show you was we can build reports. So as well as building a filter list, so you can visualize data, we can build a report, which could be a PDF report. It could be a report for all wells that have completed at a particular depth in a field, and it would build you a report summary, which is a document that you can then take and use. Well, scout tickets, for example, are other types of reports that can be built. And these very quickly allow you to extract information and combine it in some other report or format that you're compiling. We've got the web and the desktop front end. So the web front end is really useful for particularly individuals who might not be based within your office. The dbMap will be hosted in your office. But if through your intranet somebody is at the well site or they're in a different office, they can use the web interface to connect to and search through dbMap for data. It allows them to visualize what's there and then make a request for that data if they don't have the permission, for example, if they're just a browser. As a company, I mean, we help you with a number of ways of importing and exporting and exchanging data, but there's always particular data types and setups within companies that are unique, and we provide the service that would help you build a particular loader or set up a particular best practice type of workflow for a particular data type. So we're always happy to help, and it's a loader that we can then leave with you and you manage it. We're just helping you get started with something that might be new. And finally, we've been doing data management for over 20 years. Being an Australian company, we've expanded out of Australia. We have a lot of clients within Australia, and we're moving globally with new clients as we engage, and we're building on that knowledge and that experience and sharing it through development of continued development of dbMap. So thanks very much. I'll just open up the questions as I conclude, but a few names for you. As a reminder, I'm Paul Gibb, based in the UK. I have two colleagues here in the UK. There's a number in our team, but just in terms of initial contact around data management, is Kevin Ward, who's based here in Glasgow, and Nathan Balls, who's the VP for Europe, Russia, and Africa. He's also based here in Glasgow. And then Scott Tidman is our CEO. He's based in Adelaide, but just as an example, he was here last week. He works globally to support all initiatives for Petrosys. So I'll just look at the chat. I do actually see one. Which version of PPDM's data model are you using? We're using 3.8 with some extensions brought forward from 3.9. That's a question from Antoine. I'll just move that to the side. So my email's on the screen. If you have any questions, please feel free to email me. We have cloud-based demo systems, so you can we can set you up with a login at any time, and you can go through the data that I've just shown you, which is all public data, and you can evaluate and consider whether this is a tool that fits your business. And we often like to help you do that. As intuitive as it is, it's good to participate with you and understand some of the challenges or objectives that you're trying to achieve. Okay, thank you very much for your time. I appreciate you taking almost an hour to sit through this presentation.